page 11 in your notes. Review of properties of logarithms. When we think about basic logarithms, anytime you see log base b of b, that means the little number and the big number are the same number. Every time you see that, your value will be 1. Okay, because base to the exponent of 1 equals itself. Anything to the exponent of 1 equals itself. Anytime you see log base b of 1, okay, this is saying base to what exponent equals 1. Anytime you've got a 1 in your value here, your output is 0. So when we're expanding and condensing, if we can make log base b of b or log base b of 1, we're always able to simplify that to be just a numeric amount. So examples of that, here I've got log base 14 of 14. I can exchange that for no log statement at all. It's just equal to 1. And example 2, it says simplify log base 3 of 1. And log base 3 is kind of a tricky one usually. But if it's of 1, it always equals 0. Okay, we learned about the property rule of logs on Friday. And remember that your rules of logarithms go hand in hand with the rules of exponents. So our product rule, if I have log base b of m times n, so I've got a product in here, I can rewrite it as an addition statement. So log base b of m plus log base b of n. Okay, so this would be the condensed version. This would be the expanded version. When you're asked to expand it, you want everything written out where each value is its own log statement. Okay, so we're going to go both directions with this. First, I'm going to condense one. I've got log base 5 of 6 plus log base 5 of 7. I'm just going to verify that my bases are the same. It only works if your bases are the same. I'm going to multiply those two values. Log base 5 of 6 times 7 is 42. So I condensed. I went from 2 log statements to 1. Now I'm going to expand. So I want to turn log base 2 of 63 into an addition problem. Now 63 has a lot of factors, right? 21 and 3, 9 and 7. So when I'm expanding, I want to look at my other values, or I want to look at my base to find which value is going to work the best for me. I'm going to use 9 and 7 on this one. Log base 2 of 9 times 7. Log base 2 of 9 plus log base 2 of 7. And I gotta find a charger really quick. All right. Next property is a property that we use when we have something that is or can be written as a quotient or a fraction or a division problem. And sometimes it's a value that we break apart into 2 divided numbers depending on what bases we want to use or what values we want involved in there. Sometimes it's already a fraction and we just want to write it, kind of expand it out. But remember that with exponents, division with exponents goes with subtracting the exponents. So division with logs goes with subtracting the logs. So this one's going to be log base b of m minus log base b of n. Okay, so we're going to condense one, we're going to expand one. I have log base 4 of 84 minus log base 4 of 12. check that your bases match. You can't do log properties if your bases are different. But I'm going to divide those two numbers. So I've got log base 4 of 84 divided by 12, which is log base 4 of 7. Okay, and then I'm going to expand one. My value here is 9. We want to avoid using 1, so I'm not going to call it 9 over 1. I could do 18 over 2. I could do 27 over 3. I could do 81 over 9. There's an unlimited possibility here of quotients that make 9. And so again, when you're working on expanding them, you want to see what else is in your problem and find out, like, if there's another log 81 somewhere, use 81. If there's another log 9 somewhere, use 9. I'm going to use 81 divided by 9. So I have log of 81 divided by 9. And now I'm going to break it into that subtraction problem. So log of 81 minus log of 9. And notice on this one, remember, if your log doesn't have a base, it's base 10. If it's base 10, you have a button in your calculator that solves it for you. So if you were evaluating that, you would just push log button and the number 9 and you'd be done with it. All right, the product property, or no, I'm sorry, the power rule. This is when you have something raised to an exponent. Okay, so your term here is raised to an exponent. When that's the case, we turn the entire log problem into a multiplication problem. So we do whatever that exponent is times the value of the log, log base b of m. Okay, so first I'm going to condense one. This has a multiplier, so I'm going to turn it into an exponent. So I end up with log base 3 of 8 to the power of 2. But please calculate these if you're able to. So log base 3 of 64. And then I'm going to go backwards. I'm going to expand one. I've got an exponent here of x minus 1. So I'm going to make that be my coefficient to my log base 2 of 6. Okay, and then the last tool that we need when we're working with logs is just to remember that change of base formula. If we have log base b of a and we want to be able to solve it for a value in our calculator, and we know that the button in our calculator only does the common log, log base 10, we can use change of base formula, which is log of a divided by log of b. And you hit enter in your calculator and it will give you that output. Okay, so let's practice that. Using a common base, evaluate the expression below. Log base 7 of 32. And remember what that means. It's asking me 7 to what exponent equals 32. Well, it's more than 1 and less than 2, but I don't know where at in between. So I'm going to use my change of base formula, log of 32 divided by log of 7. I'm going to type it into my calculator. Make sure when you're in your calculator, when you push that log button, it automatically feeds in a parenthesis. When you put your 32 in, you've got to close that parenthesis before you set up your division problem. Log base 7. And I'm going to round to 4 decimal places. These are often irrational numbers. That means this decimal keeps going with digits forever. We don't actually know how much it is. We have to round. 1.0 0.7810 is what I'm going to put it at, which makes sense because 7 to the 1 would be 7 and 7 to the 2 would be 49, and 32 is a little closer to 49 than it is to 7, is a little closer to squared than it is the power of 1. But that's an exponent that we'd never be able to solve for if we didn't have logarithms. All right, base 10 logs are common logs and are written without a base. Log x. This is what the button in your calculator does. Log of x, log base 10. All right, we're going to go back to this page right here. And first we're going to condense some logs. So your goal when condensing logs is to try to write them as one logarithm. Log base something of something. Okay? So I'm looking at 19. I have 2 times log of 6 minus log of 9. So I see 2 properties happening here. I have the power rule and I have the subtraction, so I have a quotient rule. I'm going to do my power rule first. And I'm going to move this 2 into the place of an exponent. So I'm first going to write this as log of 6 to the 2 minus log of 9. Okay, and 6 to the 2 we know is 36. When I switch it here in a minute, I'm going to use 36 instead. Okay, now we're going to take care of our quotient rule. We're going to take care of that subtraction. And so I'm going to change this to be log of my first number, which is 36, divided by 9. And now I'm going to simplify. If you can divide your fraction, please divide your fraction. So my final answer here is log of 4, or log base 10 of 4. And that one we could evaluate in our calculator, but when your instruction is to condense the log, we're not looking for a value, we're looking for a log. So this is my answer here. Try number 2 on your own, and then I'm going to put an answer up and we'll see how you did. Number 20. Try number 20 on your own. Okay, do your power rule first. Move your coefficient into an exponent. And then your product property, I have addition. And I just multiply those terms together. Since I don't have numbers, I'm leaving it as a variable statement. So log base 4 of a to the 4th b squared. Okay, let's try 21 together. Both of my terms have a coefficient, so I'm going to take care of that coefficient first. The first one is straightforward, log base 4 of u to the 7th minus, when I take this 3 and I put it into the exponent, there's already a 2 up there. It's joining that 2 in the exponent. They're going to multiply together. So I'm going to have log base 4 of v to the 6th. And now I'll take care of the
Would you add them or multiply?
multiply it up there. And then I'm going to take care of my subtraction by turning it into a division problem. Log base 4 of u to the 7th divided by v to the 6th. And that I can't simplify. If those were both u's,
Please come to room 4.
if those were both u's, then I would simplify whatever this was. I would cancel out what I could and reduce my fraction. Okay, but I can't because I have all variables and they're different. Okay, looking at number 22, I don't have any coefficients. I have addition and I have subtraction. I'm going to do both in one go. Okay? The numbers that are addition are going to get multiplied together, and then they're going to be divided by the number that's subtraction. So I'm going to have log base 2. And in my fraction on top, I have 15 times 4. And on the bottom, I have divided by 6. And now I'm going to turn that into a value. 15 times 4 is 60. Divided by 6 is 10. My answer here is log base 2 of 10. Okay, looking at number 23. I now have 3 terms that are being added together. That's going to give me a multiply, multiply, multiply. I also have a 1/2 coefficient. I'm going to do my 1/2 coefficient here first. That's going to give me log base 3 of 49 to the 1/2. What does that 1/2 exponent do to my 49?
Takes it to 7.
Takes it to 7 because this means square root. Okay, so what I have is log base 3 of 4 plus log base 3 of y plus log base 3 of 7. So now I have a multiplication problem. I have addition, addition, addition. So I'm going to do multiply, multiply, multiply. Log base 3 of 4 times y times 7. And I'm just going to simplify that to be log base 3 of 4 times 7 is 28y. Okay, looking at number 24. I have a coefficient in front of parentheses. That means everything inside has that same coefficient. And it's a 1/3, so it's going to be an exponent to 8, and it's going to be an exponent to 27. So my first step here, I'm going to go log base 5 of 8 to the 1/3 plus log base 5 of 27 to the 1/3. 1/3 means cubed root. So I'm going to rewrite this as log base 5 of 2 plus log base 5 of 3 minus log base 5 of 3.
Can you just do what's in the parentheses first and then put the 1/3? Because I did it and I got the same thing.
Yes.
You can do that?
Yes. Yeah, distribution is the same. It takes care of doing the parentheses first. Okay, now I have log base 5 of 3 minus log base 5 of 3. I'm crossing those out because they subtract each other and they make nothing. So my final answer here is log base 5 of 2. Okay, try number 25 on your own, please. Work your way through number 25 on your own, please. Actually, let's do 25 and 26, and then we'll expand some together. Try 25 and 26.
you do the 1/4?
Take a fourth root of your number. Or type it in as 16 to the power of 1/4 in your calculator. Because it's attached to that log.
Log
One-
6.
Log
It's
16. It's attached to the log 16.
Oh, I thought, okay, never mind.
See it? Okay. Curious on 25. I got log base 2 of 2. Can I simplify that any further?
Yeah, to 1.
To 1. Okay, finish up in the next minute or so. Check your answers and then we'll move down to the bottom.
If we wrote the unsimplified ratio log 2 base 2, would that still be considered log?
Yes. No, it'd be considered right. Yes. If you, okay, so if you have a fraction left in there, if you have things that you can multiply, if you have more than one thing, then you're not done yet. But yes, this could be done. I just always like to point out that when we see one of those special logs that we can evaluate them. But I would let you answer with either one of those when we're condensing. Okay, next we're going to expand. Our goal when we're expanding is for each part of our term to have its own log statement. Okay? And when it has its own log statement, that log statement ends with just a value. So it could have a coefficient, but not an exponent. It can have addition and subtraction, but no multiplication. And we want to stretch it all the way out. So I'm looking at number 27. It says log base 6 of x, y, z to the 4th. That 4 is only touching the z because it's inside the parentheses. Okay, it's only touching the z. So I've got log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. That's my first step. I'm going to expand my multiplication into an addition problem. But now I've got an exponent that I have to deal with. So I'm taking this exponent and I'm going to move it in front of its term. So my answer here is going to be log base 6 of x plus log base 6 of y plus 4 log base 6 of z. Try number 28 on your own. Give it your best shot. And I've got an answer up so you can check your work. Okay, 29 is going to take us more steps. Okay, I've got an exponent for my whole term of 2. And then I've got some multiplication to deal with. And then I've got some more exponents to deal with. So I'm going to start with this guy up here. And I'm going to turn it into a coefficient for my whole log statement. And now I'm going to turn that into an addition problem. Thank you very And when I turn it into a multiplication or into an addition problem, I'm going to have two log statements, log of q, log of r. This 2 has to hit both. So I'm going to go 2 parenthesis log base 7 of q to the 4th plus log base 7 of r squared. Okay, now I'm going to deal with my next exponents. I've still got my 2 on the outside. And then I have 4 log base 7 of q plus 2 log base 7 of r. Okay, but I don't want any parentheses in my final answer, so now I'm going to distribute the 2. So I have 8 log base 7 of q plus 4 log base 7 of r. And there's 2 or 3 different ways to go through the steps on that. As long as you're following your math rules, you're going to get to the same ending as me.
So
Okay?
at
Yeah.
the very beginning, can I just take and distribute the
Uh-huh.
2 into the parentheses?
Mm-hmm. You'll still end up, because then you'll end up with q to the 8th or to the 4th,
Mm-hmm.
and they'll still roll to the front.
Wait, so the fully simplified version is the black ones?
Yes. Okay, try number 30 on your own, please. And again, there's more than one way to do your first step. Check your work, see how you did. I'm going to help get you started on 31. I have log of a square root. Square roots kind of don't work well with logs, so the very first thing I do if I see a radical is I change it into an exponent fraction or a rational fraction. A rational exponent. So I'm going to rewrite this as log of 7x cubed to the 1/2. Okay, now from here I have options. I could distribute the 1/2 and I could have 7 to the 1/2 and x to the 3/2. Or I can turn it into a coefficient and then do my addition part. That's the part that I want to do because I don't like that 1/2 would be on 7. That is kind of ugly. So I'm going to move my 1/2 out front. And now I'm going to break it into an addition problem. So I'm going to have 1/2 log base 7 plus 1/2 log of x cubed. Or I could also write this way, 1/2 log of 7 plus log of x cubed, and then distribute the 1/2. Okay, whichever way you can see it, but this 1/2 belongs to both pieces. And now my last simplify is to take care of this exponent of 3. So 1/2 log 7 plus 3/2 log x. I just took that 3 and I multiplied it with the coefficient I already had. Okay, I want you to try 32 on your own. That's a fourth root. Fourth root means exponent of 1/4. And I've got an answer up so you can check your work.